Hi sir, myself Shubham Jana, third sem, C1 project of signal system, topic classification of signal. A signal is any physical quantity that conveys information by varying or over time or space. Example হচ্ছে voltage of a household AC supply, daily stock price recorded at end of each day, temperature variation throughout the day. Signal is like the messenger while the system of processor that acts on the signal. The classification of signal is it is 6 type: continuous, discrete, deterministic, non-deterministic, periodic, non-periodic, symmetric, asymmetric, or order even. That's called order even. Same thing. Energy and power signal, casual and non-casual. Continuous time signal. Continuous time signal. If the signal is specified for every value in the time, then it is called continuous time signal. Characteristic exists for or a real time value, commonly represent using smooth curves. Example: voltage output of microphone before the digitalization. Room temperature measured continuously. This is called continuously. If room temperature measured, it shows continuous time signal. If is time interval short, then it will be called discrete. Then we come discrete time signal. If the signal specified only for discrete time instance, then it is called discrete time signal. Characteristic: this is sampled at every intervals. This signal can be analog or digital amplitude processed by digital system. Example: daily stock prices recorded at end of each day, or audio sample stored in the computer. This is the temperature graph of a particular day, and this is the discrete. Here is then we come analog signal. A analog signal whose amplitude can take any value in the continuous range, then it is called analog signal. Analog signal characteristic: continuous amplitude value can take any real number. Example: temperature management or ECG signal. Discrete time signal is one type of analog signal. Digital signal: a signal whose amplitude can take only finite number of values is this called digital signal. Characteristic: discrete amplitude value can take only real numbers. Digital image pixel or binary data. This is the example, and this is the binary digital signal graph. Here we analog signal, analog and continuous time signal. This is the graph. And analog discrete time signal. This is the same thing but continuous and discrete. Digital and continuous. This is the graph. Now example of digital continuous, and this is the example of the discrete digital and discrete time signal. Then we come periodic time signal. A signal which repeats itself after finite time t, then it is called periodic signal. Characteristic: repeats after fixed time t, x of t equals to x of t plus t. Example: sine wave, square wave in electrostatic. Here periodic time signal repeats itself. We can see there in bare eye. A periodic signal we see in the graph. These signal don't repeats, not follow any mathematical formula. The aperiodic signal. Energy signal. Energy signal. A signal is called an energy signal if it has finite total energy and zero average power. We can simply say that if a signal has finite energy, then it is energy signal or power signal. If a graph has a finite non-zero energy, then it is called power signal. Characteristic in here, this graph of minus e to the power minus t by 2. is example দিলে minus half to infinite of infinite g square t dt Eg equals to 0 to infinity g square t dt. For integration of 0 to infinity e to the power minus t dt. Characteristic যদি করা হয় total energy is finite. Second, average power 0 হয়. Third, exist for finite duration of signal. Power signals a signal where average power is finite and non-zero, but that every energy is infinite. Power signal is really easy to understand. Where power only in graph we can easily say power is non-zero. Pg is the mathematical form. Limit t tends to infinity 1 by t minus t by 2 to infinite t by 2 g square t dt. Pg here the answer of this 1 by 2 minus half to 1 g square t dt. Characteristic power finite energy, it's periodic. This is periodic graph. Power signal graph is one type of periodic graph. Cosine wave. Deterministic signal. The behavior can exactly predicted at any time, past or future. If you know the mathematical expression or role, characteristic wholly predictable হবে represented by mathematical expression. We predicted in this graph we see this graph next next expansion will be predicted by mathematical form. In a communication signal graph, this is the ideal graph. We can say random signal. Random signal. It is signal whose behavior can't be predicted by any mathematical expression. Here in the graph we see there is no match with the others one signal to next signal. Then we come causal signal and non-causal signal. Causal signal, non-causal signal. Sorry, here the spelling is mistake. A signal that is 0 for all negative time t less than 0 or n less than 0. Characteristic xt0, xt equals to 0 for all t less than 0 and xn0 for all n less than 0. Exist for present and future times only. Example, step function u of t and non-causal function exist t less than 0 as well as example x of t e to the power t for all t hoy. Sorry, here is spelling is mistake. Causal and non-causal. Symmetric or event signal. Symmetric, in this signal we can say this is event signal, also symmetrical signal. About the vertical axis, this means the signal at the time t ভার্টিক্যাল অ্যাক্সিসে দুদিকেই সমান হবে দেখা যাচ্ছে। আর অ্যাসিমেট্রিক আর অড সিগন্যাল, this in this signal this the graph is really understandable where this is not symmetric of the vertical axis, main vertical axis 0 দুদিকেই আলাদা, এটা asymmetrical odd signal.